dan jitu, penuh bervisi guru AYU, mencapai misi yang satu, bervisi kita bantu.
Tahniah, siaran langsung ini dibawakan khas kepada anda oleh Akademi Youtuber Malaysia. Tumpukan perhatian anda, siaran langsung akan bermula sebentar lagi. Link sijil akan diberikan di hujung siaran ini. Pastikan diisi dalam tempoh yang ditetapkan. Terima kasih.
Hi, Salam, Sejahtera, and good evening, everyone. Welcome to Pusat Tuisyen Akademi Youtuber with the joint venture of EDD Malaysia and Guru Malaysia. Bermula PERCUMA, selamanya PERCUMA. I'm Mr.Peh. Currently, I am teaching at College Tingkatan 6 Tun Fatimah, Melaka. I am a teacher on duty for this week. For those who haven't subscribed my channel, please press subscribe button to show your support to me and share today's lesson to your friends so that more of your friends can gain benefit from my lesson. Without further ado, let us start our class today. So today you will be continue our last chapter, chapter 6, light and optics. And we are going to complete our syllabus in Form 4, which will be end with the subtopic of 6.6, image of formation by spherical mirror. So we'll be taking about 1 hour to finish the subtopic today. And in today's subtopic, you are going to learn 2 learning standards. So the learning standard 1, you need to determine the position and the feature of the image formed by 2 types of the spherical mirror, which is a concave mirror and convex mirror. Okay, so let us define what is a spherical mirror. So you can just look at the diagram. Okay, so this is the hollow spheres. Okay, so the spherical mirror are parts of the hollow spheres. So this is a hollow spheres that has been cut. Okay, so you can see there is a 2 curve here, APB and APB prime. Okay, so if the outer surface of the parts that has been cut reflect light, so be here. The mirror is known as convex mirror. Okay, convex mirror. Okay, and then if the inner surface of the parts has been cut, reflect light, so will be here. Okay, so the mirror is a concave mirror. So we're using symbol prime here. Okay, so basically you can see this is a curved inward mirror. Okay, so curved inward mirror. Okay, so this will be concave mirror. So this is the reflected surface. And then here will be curved outward surface. So here will be the reflected surface. And this one will be known as the convex mirror. Okay, so that means you can just remember curved inward will be concave mirror. And then the curve upward mirror will be the convex mirror. Okay, then the next, concave mirror and convex mirror can be represented by the steel spoon, so which is illustrated by this figure. Okay, so you can see here, this will be represented as a concave mirror. So you can see the image here is actually inverted. Okay, so the concave mirror can be shown upright and inverted image with different position of object. While another one, you can see here, this will be the convex mirror. So the convex mirror basically will be only showing the upright, vertical, and diminished image. So later on, we'll discuss detail the different position of object form different type of the image for both spherical mirror here. Okay, so next here, you need to understand the optical terms of the spherical mirror. So the spherical mirror we're going to discuss here actually is both of the mirror, concave and convex mirror. Okay, so for the center of curvature, we're using a symbol C, so be here. So it's the center of spherical mirror. So you can see this is the circle, so which is represented by the hollow spheres. Just now we discussed the figure. Okay, so the center of the spherical mirror will be known as center of curvature, and we know as C. Okay, then the next here will be P. So you can see here will be P. Okay, so we know as pole of the mirror. So the center point on the spherical mirror. So will be will be the mirror. So this is the center of the mirror for both type of the mirror here. Okay, then the next term here will be the principal axis, will be here and here. Okay, so it's a straight line which passes through C, which is known as the center of curvature, and P, which is known as the pole of the spherical mirror. So we learned already at 1 and 2 here. Okay, and then the next, number 4, is the radiance of curvature. Radiance of curvature will be here, CP. Okay, we using symbol CP, represent as the radiance of the curvature. Okay, so the distance between the center of curvature and surface of the mirror, so will be this distance or this distance for the convex mirror. And here already showing by CP here in the figure. Okay, and then the next will be the focal point. Okay, so focal point is a point on the principal axis, so will be here. It's one of the point at the principal axis. Okay, so firstly, you can see the picture show the convex mirror, and you can see the F, which is the symbol for focal point, is actually behind the mirror. Okay, so you can see is the point diverge from the point after refracted by convex mirror. So you can see the light is refracted from convex mirror and diverge from point F. So let's say you extended the arrow, you may see this arrow is actually come from F, which is behind the mirror. Okay, then for the concave mirror, so the light strike the surface of concave mirror will be converge to the point after refracted by concave mirror. So you can see this is a difference for the concave mirror. So the F, the focal point, is in front of the mirror. While for the convex mirror, so the F point, the focal point, is actually behind the mirror. So this is the difference between the focal point for concave mirror and convex mirror. Okay, then the next will be the focal length. Okay, so the focal length is the distance between the focal point F to the pole of the spherical mirror, which is P, is actually here. So that means the distance here will be known as the focal point. Okay, and then the focal point is actually half of the CP. So CP is here. Okay, so that means F equal to half CP. Okay, or C will be equal to 2F. Okay, so this is the importance formula. Okay, you can take note here. Okay, so here in front of mirror, so you can see the focal point. Just now I already highlight. So the focal point for concave mirror will be in front of mirror, while the focal point for the convex mirror will be behind the mirror. Later on, we'll discuss detail for this. Okay, then number 7. So object distance, we're using symbol U. Okay, distance between object and pole of the spherical mirror. So again, P is here. So the object is here. So distance from the object to P, we know as U. So here also the same. So the distance between object to the P is U here. Okay, so this is the arrow showing the U for concave mirror, and here will be the U for the convex mirror. Then the last term here will be the image distance V, using symbol V, which is actually same as the symbol you learned at previous learning standard 6.8, previous subtopic 6.1 to 6.5. Okay, so it's the distance between the image and the pole of the spherical mirror. So it will be from image will be this, here to here, and here to here. So this will be V. Okay, again showing by this arrow is V, image to P for concave mirror, and then here will be the V will be here. Okay, so you can see here when the image is formed behind the mirror, so we know as a virtual image. Okay, while for the image in front of mirror, which is same position with the object, we know as the real image. Okay, so this will be opposite with the image formed by lens. Okay, so for lens, when the object and the image is at the opposite position of the lens, so the image form is the real image. But for concave mirror, so when the image form same position with object, we know as the real image. Okay, so I hope that you clear about this. Okay, then here will be the rule of ray diagram for concave mirror and convex mirror. Okay, so the rule is almost same as what you learned at concave lens and convex lens. So here you also need to use two of the three ray to define, to get or to determine your final image. Okay, so here firstly, so type of the spherical mirror. So as mentioned, we have two types of mirror, concave and convex mirror. Okay, so what is the difference here? Just now I also already touched that this is the focal point. So when the focal point in front of the mirror, so here will be the mirror reflected surface. Okay, so when F is in front of mirror, so the light you can see from the parallel light strike the surface of the mirror will be reflected to the point F here. So you can see all the light will be converge at F. Okay, so you can see ray parallel to the principal axis will be this all ray. Will be converge. You can see all will be converge. Okay, converge to a point in front of mirror. So the focal point is here, which is actually on the principal axis. So this is a concave mirror. Okay, so here the reflected surface here. So or just now I tell you this will be the mirror curve outward. Okay, curve outward. Okay, so you can see when the parallel light strike the surface of the convex mirror, So the light will be appear diverge from the point which is behind the mirror. So the mirror is here, reflected surface is behind. Okay, so this is a difference between the concave and convex mirror. Okay, so ray parallel to the principal axis diverge from the point behind the mirror, which is F here on the principal axis. So this is a difference between these two types of the mirror. Okay, then the next here we will be going to discuss detail how you form the image by using the ray diagram. Okay, so forming the image by concave mirror and convex mirror. So we want to forming image by these two mirror by using three basic ray. Okay, so here let us discuss about the concave mirror first. Okay, so for the first ray, so you can see the ray parallel to the principal axis will be this ray. So this is a principal axis. So this is a light ray which is parallel with principal axis and reflected. So here you can see here, this is a concave mirror which is curved inward, right? Okay, so it will be reflected through the F. So the F here is in front of the mirror because this is a concave mirror. Okay, so this will be the first ray. And then the second, a ray passing through F is reflected parallel to the principal axis. Just now, the ray is parallel and reflected through the F. Okay, now the light passing through the F and then parallel when reflected back. So this is a principal axis. Okay, so this will be the second ray you may draw to determine the or to form the image. Okay, then the third ray here will be a ray passing through C. Okay, so C just now I tell you already is actually equal to 2F also. Okay, so the light ray will be reflected back. So you can see the light pass through C will be reflected back with the same path through the C. Okay, so this will be the third ray for the concave mirror. Okay, so the F and the C is always in front of the mirror. Okay, so for the convex mirror, as we discussed already, for convex mirror, the F will be behind the mirror. Okay, so you can see here, this is a mirror. This is a convex mirror. The reflected surface is here. Okay, so, or we can note as a curved outward mirror. Okay, so you can see the mirror, the F is behind the mirror. Okay, so first rule also the same. So the ray parallel to principal axis. So this is the principal axis reflected from the F. So the F is here. So this is a surface. Then the second, so the light pass through here, F. This will be the line. Okay, so a ray that is directed towards F is reflected. Okay, so it's reflected parallel to the principal axis. Then the third ray will be a ray directed to C. So you can see the C is behind the mirror, which is 2F actually. So for example, if I say the focal point is 10 cm, so the C will be 20 cm. 2 times 10. Okay, so it will be reflected with the same path. You can see the arrow. Okay, so basically, this is a three basic ray you can use to draw the ray diagram for convex and concave mirror. Okay, so now we discuss detail for the position and characteristic for concave mirror image. Okay, so for concave mirror, so they will be more complicated, just like the convex lens. Okay, so which will be have 6 different positions we are going to discuss. Where they will be formed, you can just look at this GIF. They can be formed the real and virtual image. Okay, so let's discuss. Okay, so the hot tips here will be any two of the three rays are sufficient to draw a ray diagram. Just now we learned already, 3 rays. Okay, so you're just using 2 of the ray to draw the ray diagram. Okay, so the first we discuss when the object is placed shorter than the focal length. So for example, the focal length is 10, so that means you will be placed shorter than 10 cm, which is 9, which is 8, which is 5. Okay, so the F is here. So object will be placed shorter than F. Okay, so let me show you what is the 2 of the 3 rays are going to draw. Okay, so the first will be parallel with principal axis and refracted through the F here. This will be the first ray. Okay, then second will be the ray pass through C and then refracted back. Will be drawn like this. Okay, so you can see we can extend these 2 lines. Okay, so we can form the image here. So the image is formed here. Okay, you can see the image form which is opposite position with the object. This is the object. So the image form will be vertical. Okay, so for lens, when object and image at the opposite position, the image we know as a real image for lens, but for the mirror will be opposite. Okay, so which is here when object and image at the opposite position, the image form here will be vertical. And then you can see the length, the height of the image form is actually higher compared to object. So this one will be magnified. And the arrow, both of the object and image is upright here. Okay, so this will be the character for image form. Vertical, upright, magnified. Okay, then the next will be the object placed exactly at the F here. That means if the focal point for the mirror is 10 cm, so that means the object is placed at the 10 cm here. Okay, again we draw 2 of the ray, just we learned at previous slide. Okay, so this is the first. Okay, parallel to principal axis, then pass through the F here. Then second will be pass through C and then refracted back. Okay, so here when we extend these 2 lines, so you can see the line here will be never meet and always parallel to each other. Okay, so that means here again the image is at infinity actually, very large at infinity, and then it's upright and vertical. Okay, so you can see when for the concave mirror, if the position at F and less than F, so the image form will be vertical, upright, and magnified. So this one will be magnified also. Okay, then the next will be when the object is placed between F and 2F. So 2F will be C. Okay, so here again the first line will be this. Second line, okay, so second line we're using the object pass through focal point and then parallel light will be reflected. So that means just now we're using first and third. First and third. Right? So here we'll be using first ray and second ray. Okay, so the image will be formed at the intersection point here, which will be here. So you can measure the height and compare with the object. Okay, so here you can see the image and the object is at the same position, which is both in front of the mirror. So this will be form real image. So that means if I say you bring a wide screen here, you may see a inverted magnified image. Okay, so this is a position between F and 2F. Okay, and then the next here will be the position when U equal to C or to F. Okay, so again here we'll be using first ray, which is parallel to principal axis and pass through F. Then second, here using second rule, where the light pass through F and then reflected parallel. So here you can see the object and the image will be at the same position at C. Okay, so arrow is, image form is downward. So that means here will be inverted. And then you measure the height for object, height of image. So you can see it's actually the same. Okay, so the characteristic here will be real, inverted, same size as the object at C. Okay, then the next will be U greater than 2F. So you can see here, if I say F is 10, C will be 20. So the O here, object here will be greater than 20 cm. Okay, again, here we draw two rays. First, parallel to principal axis and pass through the F, which is in front of mirror for concave lens. Second will be this. And then you can see the intersection point is here. So this will be the arrow which is downward. Okay, so again, you can measure the length or the height for object and image. So you can see very clear that the image form will be smaller than object. Okay, so this will be diminished. Okay, will be here. Diminish. Inverted, real. This is real. Why? Just like I mentioned already, if you put a white screen here, you may receive an image on the screen. Okay, then when the object is at infinity, okay, so we're using the second ray, which is passed through the F refracted parallel to principal axis. Second, we're using third ray, which is passed through C and then refracted back. Okay, so here you can see the intersection point is here. Okay. Here. So again, here will be inverted, right? Okay, so here will be real, inverted, diminish at F. Okay, so this is the 6 different position of the object placed in front of the concave lens. So we have different characteristic image. Okay, so then here will be the position and characteristic of the convex mirror image. Okay, so here will be very straightforward for convex mirror. Okay, it will be only one type of characteristic or image will be formed. Okay, we also again using 2 of the 3 ray we already learned just now. Okay, so here will be the position where the object less than F, so the F is here. So you can see the O is represent the object. So which is represent the object. Okay, so the F here, you should draw from behind the mirror from here, not here. So this is in front of mirror. You should draw at here. Okay? Okay, so again here the first ray will be refracted, initially parallel and then refracted from the F which is behind the mirror. So this is actually the first ray. Okay, then the second will be pass through the C. So this will be actually C. So that means light will be passed through C and then reflected back with the same path. So you can see here we have the intersection point. Okay, so here will be very clear, it's upright and the size will be smaller, it's diminished. And you can see position of the object and image is opposite to each other. So this will be virtual image. Okay, so it'll be here. Okay, so here vertical, upright, diminished will be for image or convex mirror lah. Okay, again, if I say we increase the distance of U, which is greater than F, okay, you can see actually the image form is also the same. So this is the first ray, which is parallel to principal axis, and then reflect from the F, which is behind the mirror. Second will be pass through the C and then reflected back with the same path. Here will be the intersection point. Okay, so you can see here the image form is also smaller than object, which is diminished. Arrow both object and image is upright. And then the position, object, and image is opposite to each other. So this will be the vertical image. Okay, so there will be also vertical, upright, diminished image will be formed. Okay, so however, if I say you compare the image which is formed by U less than F is actually bigger compared to U greater than F. Okay, so we can conclude that. Okay, so when the object is nearer to the image to the mirror, so we bring the object nearer to mirror. So this is a mirror of the convex mirror. So the size of the image form is increases, is bigger, but still smaller than object. Okay, so this will be the difference between the convex mirror and concave mirror. So for concave mirror, if the vertical image is formed, so the object, the image will be vertical, upright, and magnified. Okay, so when you see the object at the mirror is vertical, upright, magnified, so the mirror will be concave mirror. If I say you see the image is vertical, upright, diminished, so the mirror will be the convex mirror. Okay, so later on we will discuss a few questions, okay, regarding these two types of the image formed by the concave and convex mirror. Okay, so we have already finished our Learning Center 1. Okay, so now we go to our Learning Center 2. Okay, so for Learning Center 2, so explain the application of the concave and convex mirror in life. Okay, so just now we already learned how to determine the image formed by the concave and convex mirror with different position. Okay, so what is the application for both mirror in our life? Okay, so here will be also a few examples will be discussed for each type of mirror. Okay, so let us discuss about the application of the concave mirror. Okay, so just now I also already highlighted. Okay, so for concave mirror, if we place the object equal or less than F, so the object definitely, the image form will be definitely vertical, upright, and then will be magnified. Okay, but will be providing the smaller field of vision. Okay. Okay, so what is the meaning by this? Okay, so here will be the example. So the dentist mirror will be one of the example of the concave mirror, which is actually used to magnify the teeth so that the dentist can observe the condition of the teeth clearly. Okay, so concave mirror are used in dental mirror to see the position of the teeth more clearly. So you can see here the mirror will be bring close to the teeth, so that means will be smaller than F. Okay, so the object is referring to the teeth, so the distance of object is actually here less than F. So as per what we explained on and learned just now, so for the image form for the concave mirror, where placed smaller than F, they will be magnified, vertical, and upright. Okay, so we here upright and magnified. This is what the purpose you want to place the mirror, the concave mirror, less than F here. Okay, then the second application here will be the refractor which you may find in the torchlight. Okay. Okay, so here in the figure you can see the bulb is placed at the focal point. Okay, so when placed at the focal point, so the light ray here will be reflected to the parabolic mirror. So the parabolic mirror here is actually the concave mirror. You can see it's curved inward. Okay, so for the theory where you learn already, for law of refraction, so when the light ray strike to the surface where we know as an incident ray, so this is a normal line. So the reflected ray will be reflected with the same angle. So it means here I and the R will be the same. So here that means it will be also the same. So here we have two angles. So this will be the angle and this will be the angle. So this will be I, this will be R. So you can see here, light strike to the surface of mirror. The mirror here is concave mirror. So we angle I. So this will be the normal line. So the light will be reflected with angle R, where the R and I will be the same. And when the bulb is at the focal point, so the reflected ray will be formed parallel ray to each other. Okay, so it can be used in flashlight and car headlight. And then light bulb are fixed at the fixed position, which I mentioned just now, will be at the focal point. Okay, so thank you, Cikgu Hasnitah, for join my class. Okay, so let us continue. Okay, so here generate parallel light ray to maintain a uniform intensity for further distance. Okay, so that means the purpose here is actually want to generate parallel light ray where will be let us see more clearly, especially during the dark. Okay, so this will be two of the application of the concave mirror. Okay, and then next will be the application of the convex mirror. So here I just highlight three of the examples. Actually, we have a lot of the application of the convex lens and concave lens in the daily life. Okay, you may actually get more example in the textbook or the reference book. Okay, so here the hot tips here will be the convex mirror will be form wider field of vision but diminish. Okay, so just now I also already highlight. So for the convex mirror, the image form will be always diminish, vertical, and upright. Okay. Okay, so here it will be the one of the application, which is a security mirror in building. Okay, will be this. Okay, so here will be specially used in the supermarket for surveillance purposes. Okay, so that means the shopkeeper will be able to observe the whole condition in the shop. Okay, so to prevent the things to get from others people, right? Okay, so here will be, you can see the image form is actually smaller than actual and is upright. Okay, so this is the image you can imagine for the convex mirror. Okay, then the second here will be the blind spot mirror. Okay, so it will be here. Okay, so usually mounted at the sharp corner for driver to see upcoming car on the right side. So you can see here. So the vision becomes wider, or the object becomes smaller. Okay, so the driver can see the car whether come from another side, so can prevent the car accident. Okay, then the next here will be the rear view mirror. So this is a rear view mirror in a car. Okay, so it's to get a wide angle view behind them for driver, so the driver can see the condition behind the car. Okay, so we have actually already finished our learning standard 2. Okay, so after break, we'll come back again with the about 5 question regarding the subtopic today. Okay, so let us take a break.
Our hearts beat to the city streets. We began to feel the fire. We rise like tall buildings as the chemicals, they take us higher. The night's young and it's just begun as she puts her hand in mine. We wanna chase the night, wanna dance to the light, pull stars from the sky, just two hearts running wild. Never sleep, never stop, as we shout from the top. We're gonna be two hearts running wild. Afternoon, we lay awake in bed. The glass so loud.
Hi and welcome back. Okay, so let us continue to our Q&A question. Okay, so today's I'm preparing about 5 questions. So 3 question objective and 2 question of subjective from paper 2 section A. So all the questions actually come from the trial 2023. Okay, so let us discuss together. Okay, so you may actually introduce yourself in the chat room. So who are you and come from which state and which school, so that I know that you learn together with me here. Okay, so and then you can also share your answer in the chat room so that we can discuss together. Okay, so the question 1 is actually one of the questions I take from the trial of JUJ Pahang. Question number 21. Okay, so diagram 15 shows a candle in front of the concave mirror. Okay, so you can see the mirror here is curved inward. So this will be showing that this is a concave mirror. Okay, so state the characteristic of the image can be formed. Okay, so here, firstly, we need to identify the spherical mirror. So here already stated by the question, as we already learned just now. So the concave mirror actually can form a different type of the image, which is a vertical or real, can be upright, can be inverted, can be magnified, can be same size, can be diminished. So it will be more complicated. Okay, so here, just now we also already discussed this will be where the position placed at C, which is actually equal to 2F also, right? Okay, so here, as per mentioned, we can using 2 of the 3 basic ray, and then we can determine the image formed by this position of the mirror. Okay, so here we are very clear that will be the rear, and then okay, so rear inverted and then same size as object. Okay, so answer here will be very clear. So it's actually D lah. Okay, and then the next question number 2 is also one of the question of trial exam 2023 from Kelantan. So this question is actually quite similar to the question number 1. Just the question asks about the position of the image form. Okay, just now is everything of the characteristic of the image formed by the concave mirror. Okay, but here the question only mentioned that this is a curved mirror, so that you must know that this is a curved inward mirror, so which is the concave mirror, and then the position is actually the same, placed at C. Okay, so as per discussion just now, this will be the concave mirror. You need to identify. Then second, actually they will be also the same, placed at the C, and the image form is actually rear inverted, same size, is at C. So here the question highlight the position of image form is actually at C, or we can know as 2F also. Okay, so here all the image form is in front. So you can see the question actually very kind already. Okay, so just give you in front of. So all will be in front of. So that means no problem, we identify in front of. Just here, the C will be 2F. So answer is very clear. The image form will be at 2F, which is C. Okay, so both question is actually quite similar. Just the previous question asking you about the characteristic of the image, and this question asking you the position of the image form by the object placed at C in the concave mirror. Okay. Okay, the next, okay, so I mentioned just now will be at here. The answer here will be C. Okay, then the next here will be the question number 3 from the trial SPM MRSM, question number 24. Okay, so this will be the question regarding the learning standard 2, which is the application question here. Okay, so the following shows 4 application of spherical mirror in daily life. So which application show the concave mirror? Okay, so as per mentioned just now, you may observe the image form. Okay, so actually A is a reflector in car headlight. So if you memorize, you know already this is actually the answer. Okay, just now we know already. So the light bulb is actually fixed at the F so that the light will be reflected and form parallel light ray. So answer is actually A. Okay, let's say you not memorize, you can see the image form from B, C, and D here. So the image is actually diminished and then upright. Right? You see the car is upright. So when upright together with diminished, so this will be definitely the convex mirror already. Right? You see? Okay, so the convex mirror will be formed vertical, upright, and diminished image. Okay, so for concave mirror, the vertical upright will become together with magnified when the U at the concave mirror placed at the F or S and F. When greater than F for the concave mirror will be formed real image. Okay, so this is actually the highlighted part different between the characteristic image for concave and convex mirror. Okay, so here is very clear, it's actually A lah. Okay, so same as what example we discussed just now. Okay, then we go to the next question. Here will be the number 4 question. Okay, so this is a question from trial exam from Penang for this year. Okay, so paper 2, section A, question number 3. So for the question number 3 will be total 6-mark question. And here we'll be asking you about the understanding and knowledge question. Okay, so here diagram 3.1 shows a mirror placed at the road junction. So the purpose of the mirror is to help the driver see incoming vehicle from the main roads. Okay, so here, if I say you remember what we learned just now, definitely this will be the convex mirror, right? Okay, let's say you're not sure, so you just can observe the image form in the mirror. You can see the road and the car is actually see clearly. So the image actually becomes smaller. So here will be diminished, upright, and vertical. So definitely this is a convex mirror lah. Okay, so you can see, you can observe the image in the mirror here. Okay, so the image form is diminished, but wider view of vision. Okay, so the image form is actually vertical, upright, and diminished. So vertical, upright come together with diminished. Definitely this will be the convex mirror already. And this is actually the blind spot mirror we learned already just now at learning standard 2. Okay, so answer here will be convex mirror, first mark. And then second, what is the advantage of the mirror mentioned in 3A1 here? So you can see actually you'll be given a wider view of vision for the driver. Okay, so answer here will be wider angle for view. Or you can mention wider view of vision is also one of the accepted answer. Then the next here will be B. Okay, so this will be regarding the drawing. We learned already at lesson 1. Okay, so in diagram 3.2, C is the center of curvature. So this is the optical terms we learned also just now. And F will be the focal point of the mirror. So you can see the object is placed here. So here will be front of mirror. So you can see here will be curved outward. So this will be definitely convex mirror. And the F is behind the mirror here. Okay, so we can using 2 of the 3 rays we learned already just now. Okay, so firstly, identify the type of mirror here. So as I mentioned just now, mirror curve outward. So this will be the convex mirror. And then we just need to use 2 of the 3 rays for drawing the ray diagram. Okay, so definitely, if we know already this is a convex mirror, there will be one and only type of the characteristic of image will be formed. Okay, so this will be the vertical, upright, and diminished image. Okay, so the first ray will be parallel to principal axis and then diverge from the. Okay, so here I not draw so accurate. So actually it's need to reach here. Need to reach here. Only correct. Must be reach here. Okay, then the second will be pass through C, reflected with the same path. Okay, so you can see here the intersection point will be here. Okay. Okay, so let me adjust the line. So we actually move to here. Okay, so means the object, the image form will be here. Okay, so this will be correct already. Okay, so let us see the answer together again. Okay, so you can see first ray must be passed through F. Okay, then second will be passed through the C. So here will be the intersection point. So the image form will be here. So it's upright, definitely it's diminished. Okay, so that means it will be correct. Okay, then here will be 3 marks. Okay, so the first mark will be given for your first ray. Second will be the second ray. Then the third will be your image showing with eye here. Okay, then here state the one characteristic of the image form. So it's very clear. This will be vertical, upright, and diminished. Okay, so will be one of the answer. If I say you're not confident, you just give one answer. If I say one correct, one wrong, you'll be not get any answer. Okay, so give one answer if I say you're not confident for the second one. Because here only ask you to give one character. Give the most confident one. So how you can make the answer more confident? As I mentioned, when you draw, you see the image and object is at the opposite position. Definitely this will be the vertical image. And you can see very clear that the size of the image form is very small. So this definitely will diminish. And then you can see the arrow for object and image form, both is upright here. So this will be upright. Okay, so this is how we confident to give the characteristic for the image form here. Okay, and then the next here will be the last question for today's subtopic. Okay, so this will be the question regarding the concave mirror. Just now I give you one of the example of subjective question for convex mirror. So this will be the concave mirror. Okay, so again, this is actually the trial exam question, paper 2 from JUJ Pahang for this year. Okay, for your reference. Okay, so diagram 8.1 show an incomplete ray diagram for a curved mirror with a focus point at F. Okay, so you see, firstly, actually you need to identify what is the type of mirror. So here you can see the mirror is actually curved inward. So very clear that this will be concave mirror. Okay, curve inward, this will be concave mirror. First mark. Okay, so this is a question number 8 is modification question. Okay, so here the second complete the ray diagram. Okay, so again we need to use two ray, but here one of the ray already given. So this is the third ray we learned just now, where the light is actually passed through the C and then refracted with the same path. So that means we need to draw another ray and identify the object. Determine the object position. Okay, so here we're using first ray, where will be strike to the surface of the concave mirror and then refracted through the F. Okay, so here one of the extended light, the line already given by the question, so you just need to extend another line. So you can see the intersection of these two dashed line will be here. Then your arrow will be here. Okay, so the first mark here will be 2 marks. First mark will be given for your correct ray. Second will be your image. Okay, so this will be the answer. Okay, and then the next will be modification question. Will be asked you to give the correct characteristic. Okay, you need to form. Okay, so here will be diagram 8.2 show a dentist doing dental examination using the dental mirror. Okay, so dental mirror just now we know already. So this will be using concave mirror, where the position of the object here referring to teeth must be smaller than F. Okay, so the image form will be upright, magnified, and vertical actually. Okay, so the focal length. Okay, so to make your object shorter than your focal length, so here your focal length must be longer lah. Okay, so that your object or your teeth here will be always shorter than the focal length. So that means the focal length for the mirror, for the dental mirror must be longer lah, so that we can form upright and magnified image lah. Okay, so the answer very clear, that will be long. Okay, and then to produce magnified image, right here. Okay, or you can mention here option 1, produce larger image is correct. Then the second one will be so that the object length shorter than focal length will be this. Okay, if I say your focal length is too short, so your object will be very high possible is higher or longer than the F, so that the magnified image not able to form. Okay, then the second one will be object length U. Just now we discussed already at this point. Distance of object U must be smaller than F, shorter than focal length. Why? Because we want to form magnified object. We want to form magnified image. Produce magnified image, or you can mention upright, also correct. Okay, then the third here will be the diameter of mirror. Okay, so the diameter of mirror will be here. This will be diameter. Okay, so the diameter here can be larger. Okay, can be larger or big, so that the image form can be seen clearly. Okay, larger field of view. Okay, larger field of view is accepted. Okay, so this will be the advice answer for this question. Okay, and then actually we already finished all the discussion. Okay, so that's all for my sharing about the subtopic of 6.6 today. Okay, so please click like and share of today's lesson for your friends, so that more of your friends can get the benefit from my lesson. Okay, so don't forget to follow the next physics classes, especially the Form 5 class, so which will be here on the next Friday, not next Friday, I think next 2 Friday. Okay, so 16th of February, okay, will be presented by the Cikgu Nora Hafizan. Okay, and then for the Form 4 class is actually, this will be the last for our academic year of 2023 and 2024. So we will be see you again for the Form 4 class and the new academic year, which is 2024 and 2025. Okay, so the Chinese New Year is actually around the corner. So I would like to take an opportunity to wish all happy Chinese New Year and happy holiday. Okay, so happy long time. Okay, so for dragon years, right? Okay, so I think that's all for my sharing today. Okay, bye-bye and see you again at the new academic year.
Mara semua para ilmuwan, semai ilmu kepada anak wawasan, tak kira di utara selatan, sampaikan ilmu penuh kesungguhan. Akademi Youtuber Malaysia, rangka laksana dengan jitu, penuh bermisi guru ayu, mencapai misi yang satu. Permisi kita, bantu kita, bermoto sendiri yang kita biasa, bersama kita luar biasa, berjasa demi nusa bangsa.
Akademi Youtuber Malaysia, berpadu bersatu keluarga ayu, memberi ilmu tanpa jamu, siap sedia menyumbang ilmu.
Ilmu diberi juga dikongsi pada semua generasi yang terkini, lahir generasi yang berkualiti, sedia berkhidmat pada pertiwi. Akademi Youtuber Malaysia, rangka laksana dengan jitu, penuh bermisi guru ayu, mencapai misi yang satu. Permisi kita, bantu kita, bermoto sendiri yang kita biasa, bersama kita luar biasa, berjasa demi nusa bangsa. www.academyyoutuber.com. Berusaha ayu, capai kecemerlangan, berpadu ayu, cipta kegemilangan, bersatu ayu, bina wadah terbilang, terus berjaya bersama ayu.
Berusaha ayu, capai kecemerlangan, berpadu ayu, cipta kegemilangan, bersatu ayu, bina wadah terbilang, terus berjaya bersama ayu.
Mara semua para ilmuwan, semai ilmu kepada anak wawasan, tak kira di utara selatan, sampaikan ilmu penuh kesungguhan. Akademi Youtuber Malaysia, rangka laksana dengan jitu, penuh bermisi guru ayu, mencapai misi yang satu. Permisi kita, bantu kita, bermoto sendiri yang kita biasa, bersama kita luar biasa, berjasa demi nusa bangsa.